Alright, in this video we're going to run through the answers for the personal pop quiz assignment. So let's take a look. The first ones here are basic special right triangles. So we are working on finding all of the sides based on the given information. So what we have here is a 30, 60, 90 in which we are given the hypotenuse. And so if we look at looking for the short side is the hypotenuse divided by 2. So 21 over 2 gives us the short side. If we go to look for the long side is the short side times the square root of 3. And so the short side was 21 over 2, and that's times the square root of 3. And so our long side should be 21 square root of 3 divided by 2. If we look at the next one here, this is a 45, 45, 90. We are given this leg is 13, so this leg is 13. The hypotenuse is the leg times the square root of 2, so that is 13 times the square root of 2. Number 3 is a 30, 60, 90. In which we are given the hypotenuse. So therefore, to find the short side, that would be the hypotenuse divided by 2. 16 divided by 2 is 8. And here's our 30-degree angle opposite that side. That's our short side right there at 8. The long side is the short side times the square root of 3. And so that is 8 times the square root of 3 for the length of the long side. All right, looking at number 4, we have a 45, 45. We are given the leg is 5 times the square root of 10, so we know this one is as well. And so when we go to figure out the hypotenuse, it's the leg times the square root of 2. And so that is, the leg was 5 times the square root of 10. Times the square root of 2. I can multiply the 10 and the 2 to get the square root of 20. The square root of 20 has a perfect square factor of 4. That 2 pops out on the outside and gives us 10 times the square root of 5 for the hypotenuse. And so this should read 10 times the square root of 5. Looking at the next one here, number 5, 45, 45, 90 triangle, we're given the hypotenuse, so the leg is the hypotenuse divided by the square root of 2. So that's 9 divided by the square root of 2. We do then need to rationalize multiplying by 1, which is the square root of 2 over the square root of 2 in this one. And we get 9 times the square root of 2 divided by 2. We would have to look to make sure that 9 divided by 2, that can, if it can reduce further without creating a fraction or decimal, we would. It doesn't, so then that is our leg for both sides. And number 6 is a 45, 45. We are given the hypotenuse at 9 times the square root of 6. So we're going to take the hypotenuse and divide it by 2 to get the leg. When we do that, we see the square root of 6 divided by the square root of 2. We can divide that and get the square root of 3. So our leg measurements, both of them, are 9 times the square root of 3. Number 7. Number 7 is a 30, 60, 90 triangle in which we are given the long leg, the leg opposite the 60 degrees. So therefore, to get the short leg, we take the long leg and divide it by the square root of 3. We then need to rationalize. We end up with 42 times the square root of 3 divided by 3. We can then take 42 and divide it by 3, and that is going to give us 14 times the square root of 3, which is our short side. To find our hypotenuse, all we need to do is take this 14 times the square root of 3, multiply it by 2, and that's how we get the 28 times the square root of 3. Number 8 is a 30, 60, 90. We are given the long side. And so to find the short side, we're going to take the long side divided by the square root of 3. We then need to rationalize. And when we do, there's nothing that we can simplify. And that becomes our short side. To get our hypotenuse, all we have to do is take this short side and multiply by 2, and that makes that 20 times the square root of 3 over 3. Number 9 is a 30, 60, 90. And we are given the short side at 20 here. And so if we want the hypotenuse is 2 times the short side, which is going to give us 40. And the long side is the short side times the square root of 3, and so that's going to give us 20 square root of 3. Okay, we're going to move on to some more problem solving, where we're still using those special right triangles. Okay, so if we look at number 10, if the diagonal of a square is 15 times the square root of 2, find the area of the square. So here's our square. The diagonal of the square is 15 times the square root of 2. Find the area. Well, to find the area, we would need these two measurements. And if this is a square, that means each one of these angles is 90 degrees. And if this is our diagonal, that means that each one of these angles now are 45. So what we have here is a 45, 45, 90 triangle in which we are given the hypotenuse, and we need to find these legs. And so if we take the leg, to figure out the leg, if we take the hypotenuse and divide by the square root of 2, that would be 15 square root of 2 divided by the square root of 2. These are going to cancel out. That gives us the legs are both 15. And then if we are looking for the area, then we know that that is 15 squared, and that is going to give us 225 units squared. In number 13, the perimeter of the square is 44. So if what we know about a square is that we have these sides that have the same measurement. If it's 44, we divide by 4. That means each one of them are 11. We need to find the length of the diagonal. So if this is a diagonal of a square, that means this is 45, this is 45, this is 90. If these are our legs, to find the hypotenuse, we just take the leg times the square root of 2. And so this is going to be our height, our hypotenuse, which is the length of the diagonal. So right there is what we were looking for. Number 11, if the area of an equilateral triangle is 16, find the area of the triangle. Well, if we know that this side is 16 and this side is 16 and this side is 16, then we know a couple of things here. First, we know that this is going to be 8. Oh, sorry, hold on one second. All right, so if we look at the area here, if we take and we drew this in here, if these were all 60 and we drew this in, that means this is going to be a 30. And so this is a 30, 60, 90. If this is 16 and that's the hypotenuse, the short side is the hypotenuse divided by 2, which is going to give us 8. And then this would be the long side. And so the long side is the short side times the square root of 3, which is 8 times the square root of 3. And then if we wanted to find the area, then the area is going to be equal to 1/2 the base times the height. So here's the area, 1/2 times 8 times 8 times the square root of 3. That's going to give us 64 times the square root of 3 units squared, excuse me. If we look at number 14, the diagonal of a square is 12 inches. Find the length of a side and the perimeter, okay? So if we have a square, we would know all four sides are going to have to be equal. The diagonal is 12, okay? If I take a square that has 90 degrees and put this diagonal in, that means this is a 45, 45, 90, in which I know the hypotenuse and I need to know the legs. So I'm going to take the hypotenuse and divide by the square root of 2. So that is 12 divided by the square root of 2. I will then have to rationalize the denominator, and that's going to give me 6 times the square root of 2. So that is the length of a side. I then need to do the perimeter, and so all I do is add up. I've got 6, 12, 18, 24 times the square root of 2 inches for the perimeter. Number 12, the perimeter of an equilateral triangle is 24 inches. Find the length of the altitude. So here we have, if this is an equilateral, and that means that each of the sides are going to have to be 8. So this is 8, this is 8, this is 8. But when I draw my altitude in here, that means that from here to here is 4. And then if I know that this is the short side and I need the long side, that means I'm going to take the short side and times the square root of 3, which is 4 times the square root of 3. Now, if I wanted to, I could do this same problem. So if you take this part right here and you put it here, notice that you could do this without using our special triangles. We can use the Pythagorean theorem. And so if we're still trying to find the altitude, it's just taken out of that picture now, that we would say that we have 4 squared, we're looking for this, plus x squared, equals 8 squared. So that's where I got that. Complete my squares. Move the 16 over. I get x squared equals 48. When I go to square root this, there is a 16 that's a factor, so that 4 pops out, and I get 4 times the square root of 3. And so that gives us this. And so that's kind of what we've talked about before, is that knowing these special right triangles saves us from doing a lot of Pythagorean theorem. And we're going to see that more often.